Good morning, Year 5. Miss Biggs here. Welcome to your Thursday lesson. Can you record today's date and learning objective? We're going to recap fractions that are greater than one whole in your book and then do your flashback 4. Pause the video, then come back to me for the answers. Here's the answers to your flashback 4. To do number 1, you look at what do I do to 12 to get to 4? We divide it by 3. So we do the same to the numerator. 9 divided by 3 is 3. 86 divided by 5 is 17 with a remainder of 1. Number 3, work out the perimeter of the rectangle. You can see here 14 and 8. We can label the other sides. We add them all together and get 44 millimeters. Number 4, when we add the numbers together, we get 1,244. The time on the clock you can see is just before 10, therefore it is 9, and 2 minutes before 10 o'clock is 58. So it's 9:58. You can see how to record it in 24-hour clock. Let's move on to today's learning. So today we're going to recap our learning on fractions when they are greater than one whole one. To help us, let's get ready with some skills. Number 1 and all the way to number 4. Pause the video, have a go, then come back to me. Let's have a look then at number 1. 24 divided by 4 is 6, because 4 times 6 is 24. Number 2, how many tenths in one whole? There will be 10 tenths. Number 3, if there are 10 tenths in one whole, how many will there be in 2 wholes? That's 10 and 10 more, so that's 20. And number 4, how many hundredths are there in 5 wholes? Well, how many hundredths in one whole? There will be 100. So how many will there be in 5 of those wholes? There'll be 500. We're going to use those skills today. Have a look. What have I shown here? I have one whole bar and it's split into 7 pieces, and 7 of those are shaded in. So we can see that one whole here is 7/7. What about here? It's the same as the top bar, but only 2 are shaded. Therefore that is 2/7. Let's have a look at what we've got here then. We can see one whole bar is shaded in with 2/7 on the second bar. There are 9/7 then altogether, because 7 add 2 is 9. Let's have a look at that again. 7/7 is the same as one whole one, and we have 2 more 7s on the second bar. 7 add the 2 makes 9/7 altogether. 9/7 we can therefore say is equivalent to one whole and 2 more 7s. Have a look here. What does the bar split into? 1, 2, 3, 4, 5, 6 pieces, and 2 are shaded. So that's 2/6. In this second bar, what have I got? Yeah, I have 5/6. So what happens if I want to add those 2 together? You can see that if I have 2 and 5 more, 2 add 5 makes 7. So there are 7/6 altogether. Now you can tell from that that will be more than one whole, because 6/6 makes one whole one. So 7/6 is one more. Let's look at how we could show that on the bar. We could then take 4 from this bar and attach it to that bar, and can you see it makes 6/6, one whole one, and then we can see there is 1 piece left over on the second bar. So we have 1 whole and 1/6, and that's the same as 7/6 altogether. 7/6 therefore is 1 whole and 1/6. Pause the video here and have a think. What can you see on these bars? Let's have a look at that together. In the first one, each bar is split into 5 pieces, so they're fifths. How many are shaded? 1, 2, 3, 4, 5, 6, and another 5 is 11. So there are 11 fifths shaded in altogether. So 11 fifths, how many holes would that make? Well, let's have a think. Counting 5s, 5, 10. How many did I get there? There were 2. 2 holes got me up to 10 fifths. And then to get to 11, that's 1 more fifth. 2 holes and 1 fifth. Let's have a look at number 2. How many halves are shaded? 1, 2, 3. So there are 3 halves altogether. 3 halves is equivalent to how many holes? We've got 1 whole bar shaded in and 1 half shaded in. Your turn, please, to have a go at questions 1 to 2 on the worksheet. And I've shown you how to lay that out in your book. Just a quick reminder though, you can come back and use this fraction rule at any point to help you, because you can see how many pieces it takes to get to a whole one at the end of the bar. The end of the bar is 1 whole one, so if you get to there and there are more left over, then you know you've got more than 1 whole one. Lay out in your book. So number 1 you will need to stick in. Number 2, I've shown you how to record it in your book yourself. Have a look. Each piece is 2 squares long to make the thirds. So you can see a whole one's made up of 3 thirds. And to get to 5 thirds, I had to draw a second bar and shade 2 more in. So that's 1, 2, 3, 4, 5. 5 thirds. 5 thirds is the same as 1 whole bar and 2 thirds left over. So we would record that as the same as 1 whole one and 2 thirds. Look carefully at how I've done 1 whole one taking up 2 squares, and then the fraction's easy to lay out. Have a go at all of question 1 and 2 and come back to me when you've done. Let's have a look at the second part of our lesson. Here you can see 12/6. This is called an improper fraction because the numerator is larger than the denominator. 12 is larger than 6. Let's draw it out then. So each bar must be split into what the denominator tells me. So it's split into 6. We've got 6 of those, making 6/6, but I'm not there yet. I need 12/6. So I draw another bar. How many more after 6 until I get to 12? Yeah, that's another 6 pieces. So another 6/6. So 12/6 is equal to 2 whole bars. Let's have a look at this one. What am I going to split my bar into? Correct, 6 pieces. And I've got to keep drawing bars of 6 until I end up with 18 shaded. So I've got 6/6 shaded in, that's 1 whole. I've got another 6/6 shaded in. Now that's got me up to 6. Add 6 is 12. I'm not at 18 yet. Draw another bar and shade it. And that's another 6/6. 6, 12, 18. So 3 whole bars were shaded to make 18/6. Let's have a look at that relationship then between the numerator and the denominator. What would I do to 6 to make 18? I'd multiply by 3. What would I do to 18 to get to 6? I'd divide by 3. So we can see that 18 is 3 times greater than the 6. That's why it's 3 wholes. Let's have a look at that. Could you apply the same logic to this one? Let's draw it out first. So each bar is split into 5 pieces. I've got 5 of those, but I'm not at 20 yet. I've got another 5, that's 5. Add 5 is 10, not there yet. 5 add 5 add 5 is 15, not there yet. Add another 5 is 20, I am there. How many whole bars are shaded? There are 4 whole bars. So let's look at that relationship between the numerator and the denominator. We're saying it makes 4 wholes. Let's see if there's a quick way to work that out. What would I multiply 5 by to get to 20? 4. What would I divide 20 by to get to 5? 4. So we can see the relationship there is that 20 is 4 times greater than the 5. So the answer is 4 wholes. Let's have a look at this one. The relationship can't be done the same way because 6 does not fit into 10 exactly. Let's draw it out to help us see what happens here. So we divide our 1 whole bar into 6 pieces. We shade in 6 of those to make 1 whole, but we're not there yet. If that's at 6, how many more do I need to shade on my second bar to get to 10? There's my bar, and I'm going to shade in 4 more pieces because 6 add the 4 makes 10. So I have 1 whole bar shaded in with 4 6 left over. Apply that thinking to these questions just to test how you get on. Please feel free to draw the bars, remembering that the denominator tells you how many in each whole bar, to help you work it out, or use the multiplication to help you work it out. Pause the video, have a go, then come back to me. Let's have a look at how you did. How many 3s fit into 11? 3, 6, 9 is the highest we can go. That fits 3 whole times. To get from 9 up to 11, we'd add 2 more. So we've got 3 whole ones and 2/3. How many 2s are there in 9? 2, 4, 6, 8. There are 4 of those, and that gets us up to 8. What would I add to 8 to get to 9? 1 more. So the answer is 4 wholes and 1/2. How many 7s in 20? 7, 14 is the highest I can get to. So that fits in 2 times. To get from 14 up to 20, what do I need to add? I'd have 6 7ths left over. Let's apply that thinking to this one. Have you noticed the numerator is the same? I'm going to compare them, but the denominator is different. You can still use what we've just done. Think how many 2s go into 7. Think how many 5s go into 7. Let's draw it out to help us visualize that. So here I've got 2 halves, 4 halves, 6 halves, and 1 more half makes 7 halves. You can see here I've got 3 whole bars shaded with 1/2 extra, so that's 3 1/2. On this side, each bar will be split into 5. So there are 5 fifths, and there will be 2 more fifths to get up to 7 fifths. So you can see here there is 1 whole bar with 2 fifths. On this side, there are 3 whole bars, so that is much more. So this side is greater than this side. There is a rule we can pull out of that. When the numerators are the same, the greater the denominator, you can see here the 5 is greater, then the smaller the fraction is. Let's have a go with this one. Apply how many 6s into 24, how many 4s into 16. Let's visualize that. It fits in 4 whole times. It fits in 4 whole times. So they are equal because they're both equal to 4 wholes. Pause and have a go at these ones. Let's have a look at those answers. Greater than, equal to, less than, less than. I'd like you now to have a go at the rest of the questions on the worksheet. Remember, you can go back and look at any of the questions and any of the methods as you go along. Here I've shown you how to lay it out. You can pause and look if you need to. And I've shown you how to do the extra challenges with some sentence stems to support you. Please feel free to pause and look at any part of the video